so awkward. That's the sound of Cynthia turning the camera on. It's okay, Cynthia. It's been a while. So we had our swimming pool, and we had the function L of t. And what did L of t represent again?
Water.
The rate of water.
Not just the water. When you say the water, that's not specific. Is that the temperature of the water? Is it the color of the water? L of t is what about the
The
water?
rate at which the water is leaking.
Right, L of t is the rate that it's leaking. I'm going to write it this way. It's how fast the water is leaking. That's meant to be a hint. If L of t represented how fast the water is leaking, I want to get a whole bunch of hands on this. What does that definite integral represent? If L of t is how fast the water is leaking, the definite integral from 0 to 10, Salma, what's it going to be?
The amount of water.
One more time.
The amount of water.
The amount of water, if L of t is how fast the water is leaking, the best way to think about it, Salma, I think is going to be, if L of t is how fast, then this represents how much, right? Like how much water, let's finish this thought off, how much water leaked from when to when?
From 0 to 10 minutes.
From t equals 0 to t equals 10 minutes. I care greatly about that. And now we have to go back and have a conversation about the units. L of t, what did I say L of t had units of?
Gallons per minute.
L of t is gallons per minute. Janaea, thank you so much for being there for me. So L of t from 0 to 10, L of t is measured in gallons per minute. And you guys know this, we've played this game before. L of t is gallons per minute. The dt is measured in minutes. So what do the units have to be?
Gallons.
They have to be gallons. And I hope that makes sense because you just said it's how much water leaked, and this is going to have a units of gallons. How's everybody doing with this? Totally meant to be a review, like we've got this, it's under control. Perfect. Today it's time to revisit the swimming pool problem and expand our thinking by considering a second rate function. Oh, so good. A of t, which will represent the rate at which water is being added to the pool, also measured in gallons. Josue, can you read the situation?
A swimming pool originally containing 10,000 gallons of water. Water is being added into the pool at a rate of 80 gallons per minute and leaves the pool at a rate of L of t gallons per minute.
Okay, three things going on in this situation now. What are the three things? What are the three things? What are the three things that you see? Cassandra, what's one of the three things happening in that situation?
But there was 10,000.
There's 10,000 gallons when?
Originally.
Originally. What's the word for that? There's a special word for that. We talked about this last week.
Initial value.
It's the initial value, right? So I don't have an empty pool. I have 10,000 gallons at t equals 0. Got that one? What's something else happening in this situation? We've got that 10,000 gallons in the beginning. What else?
15 added at a rate of A of t gallons per minute.
Okay, so I've got water going in. This is added in gallons per minute. So that's a little bit new. The last time when we had this situation, right, you guys called me over to look at your leaking swimming pool, and all we had was water coming out. Now I've got water in there in the beginning, the initial value. I've got A of t is water getting added, and I've got L of t water coming out. Big picture, we're okay? I'm not giving you an equation, just some information. Based on this, I want you guys to play around with this for a couple minutes. Show me what you can do. Problems 1 through 6, I'm giving you a situation. I want to know what's the calculus you would use to solve this problem. So what's the calculus you use to figure out the amount of water added to the pool in the first 10 minutes? I'll give you guys a couple minutes to play around with this. Average value, 5 to 0. Can I get the average value? Oh, right, we don't do that anymore. Right, because at this point I'm not taking that. So
Right, so,
like at this point, it's you don't get a grade on it, or you do get a grade. average value. Those are solutions. And the average value. All right, average value stuff. Thank you.
So just eight, because it's enter will not be necessary. L is leading, A is adding.
How much is water leaks
From the pool during the first 15. Just how much the pool uses. It says how much. That's the rate.
I'm wrong,
That's why we're gonna blame him.
How much? Because I was asking how much water.
Wait, don't we expect that?
The amount of water that leaks from the pool during the 10. So is that the same thing as number 2, but it's
All right. Quick show of hands. Number one, the amount of water that has been added to the pool during the first 10 minutes. I walked around, I saw some folks that are saying 10,000 plus the definite integral from 0 to 10 AFT dt. I've seen definite integral from 0 to 10 AFT dt. And the last class, I saw some folks that had A of 10. Okay, hold on, we're not going to laugh at them. How many of you guys would go with the first one? Nobody. No. Thank you for being honest about that. So you were thinking 10,000 plus the definite integral from 0 to 10 AFT dt. Or you're the only one that had that. Somebody explain, why not this one? Why not this one? Only 2 people, 3 people, 4 people? Fabricio, why not this one?
Because he's not asking for the total amount.
There's 2 questions I could be asking here, Brianna. There's how much is in the pool at time t equals 10. And there's the question of how much did I add in the first 10 minutes? How much was added? That's what this definite integral represents. Just, this is how much is added. A of 10, why not A of 10? Nobody wanted to go with A of 10. Miguel, why not A of 10?
Oh, because that's how much water is added at 10 minutes. Like
No, that's not what it represents. It's not how much. You will never start your sentence with how much for a problem like this. What are you going to say, Jasmine?
It's on how fast the water is added.
It's how fast the water goes into the pool. It's different. So definitely not A of 10. Nobody was tempted into this one, right? Brianna, are you okay that it's not this one? Okay. And so everybody's good with the integral from 0 to 10 AFT dt? Good. All right, how much water leaks from the pool during the first 15 minutes? Cassandra, how are you feeling about number 2?
I said 15, and then the little thing, and then
Okay, the integral?
0. Yeah,
Where's the 15?
on top.
On the top. And the 0? On the bottom. What's the function?
AFT.
L what?
No, AFT.
AFT. How much water leaks from the pool?
Wait, no, LT.
Okay.
I had L.
Yeah. Okay, so the integral from 0 to 15 LFT dt, this is how much water leaked. All right, number 3, the amount of water that is leaked during the 10th minute. And this keeps showing up on the homework. I've asked you things like during the 3rd year, during the 2nd minute. So how much water leaks? I'm pretty sure there should be a whole lot of folks out there that have L of TDT. And if you're going to make a mistake, it's with the limits. What are the limits? Let's get some hands on this. I see Salma, I see Miguel, I see Janaea, I see Cassandra. Janaea, what are the limits going to have to be?
9 to 10.
One more time.
I think it's 9 to 10.
From 9 to 10? Anybody have 0 to 10? You had 0 to 10? You had 0 to 10? 0 to 10 would represent how much water leaks during the first whole 10 minutes. What this question says is just during the 10th minute. The 10th minute starts at t equals 9 and goes till t equals 10. If you're not sure about that, think about this question. When does the first minute start? The first minute, when does that first minute start?
0.
Starts at time 0 and it ends at t equals 1. That's why for 10th minute we're going to go from t equals 9 to t equals 10. Okay? All right, number 4. At what time t will a total of 5,000 gallons of water been added to the pool? I know I'm adding water. That 5,000 though, that's the goal. How long do I add water for until I get to 5,000? I know I'm going to start at time 0, but when do I end?
T.
At what time t will a total of 5,000 gallons of water been added? At what time do I stop?
T.
T. And this is something that we were really good at before winter break. There's a problem here. There's something I really don't like here. Brianna, what's the thing I don't like here?
Oh.
You'll get confused with the variable.
I don't like using t up here as a limit of integration and as a variable of integration. But the t, they're saying it's already been claimed. It's the time that you turn it off. So don't change this guy here. You're going to have to change this. Like call it a of x dx or a of f for Fabricio, a of j dj for Janaea. That works. Number 5, total amount of water in the pool at the end of 1 hour. Looks like a lot of you haven't gotten there yet. Take 1 minute. Get it for me. This is at least a 2-pointer. At the end of 1 hour, how much do you have?
Mm-hmm.
How much water in the pool?
Because after 1 hour is in, that's it. 60 minutes. Oh, no, that's it. 1 more hour. Here's my question: is it does? I don't know.
Flip it back over. Focus, girl, focus. Okay. So the good news, everyone seems confident that it's 10,000 plus, right? Because I want to know how much is in the pool. So 3 things happen. There's 10,000 in the beginning, plus how much did I add? A of t dt from 0 to 60. And that's not the end of the story. Claudia, do you know what that's not going to be the end of the story? Okay, you're not sure. Thanks for the honesty. I want to know how much water is in the pool. What's happening in this pool situation? What are the 3 things?
Water's being added
Water's being added into the pool. What's another thing?
and it's leaving the pool.
Water's leaving the pool. And the 3rd thing was actually started with water in the pool. So if I want to know how much is in the pool at the end of 1 hour, it's the 10,000 in the beginning, plus how much did I add? And we're not done yet, Claudia, what? I've got to figure out how much did I lose. And so I heard, I think Josue said, I know we need to use L of t dt, but I'm not sure if I'm adding or subtracting here. Did you eventually get over to subtracting? Why subtracting?
Because it's the amount leaving, so it's negative.
Right, it's the amount leaving. I'm going to take this water away. Okay, one more that we're gonna do together. At what time T will the pool be empty? Pool's empty. Salma, what do you know if the pool's empty?
There's no water. There's no water.
There's no water in the pool. Well, three things have happened. I started with my 10,000 gallons. I had water that I added. I had water that I lost. And the end of the story is I have no water. The 10,000 that I had in the beginning, plus how much did I add, minus how much did I lose, gets me to 0 gallons of water. What we haven't figured out though are my limits of integration. Melissa, what are your thoughts here? At what time T? The magic of T is this is when the pool is actually empty. That value of T is going to be one of your limits of integration. It's going to be when I actually stop adding water in. When do I start? 0. For L of T? 0 to T. And of course, if you want to hold me to really high expectations, change that T in here. Make it A of X, dx, call it anything you want except one of the letters that we've already used. Everybody mostly all right?
Yeah.
Okay, big picture, I think we're in a good place. What I want to be able to do is give you guys some good practice time. So, let's flip it over together. Wow, tough crowd. Tough crowd. Jessica, why are you looking at me like that? Jessica's like, that's not what you look like. I know that's not what I look like. My head's not that square. And I would never wear Birkenstocks like that. I have nicer chanclas. All right. So, finally the calculator comes out. Okay, this is still the swimming pool problem. There's still a lot going on, but now you've got equations, you've got stuff that you can use your calculator to help you evaluate. This is totally calculator active. In the next 6 minutes, you guys should be able to get everything set up and at least complete A, B, and C. I want us to talk about D and E together, whole group. If you need some help, let me know. Let the cups do the talking. It's totally natural. Miguel, can I get you to drive my laptop?
See, it's all at Alejandro's.
All right. So if you could do all the work that you would do on my computer instead. Now, some friendly advice, because I've been around the block with these problems for a while. It's good to graph the functions on the graphing calculator part and do all your calculations on the calculate part. Your setup is great, and I'll tell you, you're getting the right answer. So those things are good. But if you're going to have to do this function, that's going to have to type it. Right? So I'd rather have you graph it once and use that from now on.
goes inside though.
What's the specific centimeter gallons or is this
Remember, answers always need to be accurate to 3 decimal places, unless for some reason the problem says something else. Units are always important. So Miguel's doing a good job getting things set up. One of the things I pay attention to whenever you're using the calculator, if they give you like a domain restriction, use that for your window. All right, do we have a domain restriction in this problem?
Yep.
Right, we're going from 0 to 60. So I want to set my X-min, we're going to go for 0. Miguel? Just click and delete. There you go. You're probably going to have to play around with the Y-min and the Y-max for a little bit to get a good window.
Yeah.
But can I just make the Y-min 0 since
Why not? And I'll tell you, just for the sake of time, Miguel, try 200 for Y-max. You don't have to use 200, but I think 200 will give you a good value. Just give me a quick thumbs up if your graphs look like the ones Miguel's given. If it doesn't look like the graphs, there's 2 big reasons that this may not look right. Number 1, because we're working with sines and cosines, make sure you're in the right mode. And the right mode is radian mode. Radian mode has to be radian mode. The other mistake that often happens is when you're doing like those division functions, if you're doing a rational function, make sure it's 3,000 the whole thing being divided by x plus 10. So if that's set up, one more strong recommendation I would make for you guys is this. You've got 2 completely different functions. Label them so that you know what you're talking about. So like the red function here, the 3,000 divided by x plus 10, that's f2, but what function name is that really? Is that a or l?
L.
That's L of t, and the L of t stands for leaving. Okay, so then the blue one, that represents F1, that's A of 2, this is water adding. We're going to do a lot of these multiple rate function problems this week, and I want to make sure you're getting set up for success. All right, part A, determine the amount of water that has been added to the pool during the first 10 minutes. When I took a quick lap around, I saw most folks have that as their definite integral. 0 to 10 A of t dt. Fabricio, what'd you get for your number?
644, 880.
644.880. I like that answer. I don't love it. There's a couple of reasons why I don't love it. Brianna, why don't I love it?
Because it says round to the nearest gallon.
Round to the nearest gallon, so we're going to have to call this 645. And even with that, like it, don't love it, I need 645 gallons. If I'm scoring this like I would score the quiz, getting the right setup is worth 1 point. Getting the right number with the units worth 2 points. How many of you guys would have honestly earned both points? Okay. B. B, determine the total amount of water in the pool at the end of 1 hour. I'm going to call this a 3-pointer. Irene, have you had a chance to finish part B? What'd you do for part B?
10,000
So 10,000
plus the definite integral of
A of t
from 0 to 60 in respect to t
from A, yep,
minus the definite integral of L of t from 0 to 60 in respect to d.
okay. And what'd you get for an answer?
10,218.939 gallons.
10,218.939 gallons. So if I'm scoring this, I'm going to go with 1 point for using the initial value. I'm going to say 1 point for getting both of these integrals with the right limits of integration. And the third point coming in over there. How many guys would have picked up all three? We're in a good place. And this is like the last thing we're doing in this unit. Just everything's going to come together. You okay? All right. Part C. Part C, create an equation, create an integral equation that can be used to determine the amount of water in the pool at any time t. I don't actually want a number this time. I want an equation. I want a function. Miguel, can you, if you haven't done it yet, can you do the part B on the calculator? Or just hit the tab. I'm sorry, not the tab, above the tab. It's the little toggle button. Alright, part C. I want an equation W of t. This has to work for all values of time. For example, like what you did if it was times 60. If we can come up with an equation that works all the time, then we get to use this in some pretty clever ways. So it's going to be 10,000 plus the integral from 0 to t, a of t dt, minus the integral 0 to t, L of t dt. Thank you for holding me to higher expectations here. A of x dx, L of x dx. Do you get that? All the points. This works for any value of t. Just like you did at like 60 minutes, it's your 10,000 plus how much you added, minus how much you lost. That's your function. Cassandra.
Why did you change the t and the...
Why did I change the t to an x? I'm being really, really picky here. One of the things that if I'm holding you to the highest bar possible, if you're using a variable for your limit of integration, you don't want to use the same variable in here. So you change this variable. Let's wait.
So in case of a test, if we forget to switch like t to x, will we use points?
How many boxes of cookies have you purchased?
0.
Yes, you would lose points. Don't go do it now, Miguel. You get a demerit for that, but your order would be valid. Okay, so everybody's good at the setup? Now, here's something that some folks have done in the past. Does that count? Is that legal?
No.
No.
I don't think
Yes,
so.
yes. It's subtraction.
Okay, how many guys would say that this is legal? This may not be what you were thinking to do, but it's legal. Melissa, why is it legal?
Because if you're like adding or subtracting and you do it, and then you can just
Begins with a D,
distribute.
ends in distribute.
Yeah. That's it.
Right. With integration, you can distribute that definite integral if you're doing a subtraction problem. The other place you can distribute?
Addition.
Addition. How about multiplication?
No.
Nope, and not division. You can distribute over addition and subtraction, but that's only going to work if your limits of integration are the same. Starting at 0, ending at t, this works. Big picture, we're okay? Good, all right. And we've got the value. Miguel, take me back to the graph. D and E I want to do with you guys together. Okay, part D, during the first hour, on what interval is W of t increasing? Before we do any math, what does that even mean? What does it mean that the water level is increasing? Don't overthink this. What does it mean? Jessica, what does it mean? Water level is increasing. Water is being added, but water is always being added into this pool, right? Salma, what has to be happening?
Water is being added at a faster rate than it is leaking.
Okay, other thoughts? What would it take for the water level to increase? Janaea, what would have to happen?
AFT is greater than wait.
I heard A of t is greater than L of t. I heard water is being added faster than water is coming out. Abel, what are your thoughts?
I was gonna say that all of it together is greater than 10,000.
All of it together is greater than 10,000. So let's actually look at the graphs. So, if you think the water level is increasing, I want to see your thumb go up. If the water level is decreasing, thumb down. If you're not sure, thumb sideways or in your eyeball. Either way, it's fine with me. But all 16 of you all. This moment in time right here. Is the water level increasing, decreasing, or no idea? Be honest. At this moment in time, the red function is how fast water is leaving. The blue function is how fast water is increasing. I think I went over right over here. The water level over here at this point is decreasing. Water level over here is decreasing. Claudia, how did you make that decision?
Well, I was looking at the second equation of
Yeah.
2. It looked more steep.
Okay, so you were going for a steepness thing. So it looks steeper here than this guy over here. All right. How about over here? Take 3 seconds to think about that. This value of t over here, water level is increasing, decreasing, or not sure? Water level is right over here. Look at the graphs. It has everything to do with the graphs. The blue is how fast water is leaving. The red is how fast the water is... I'm sorry, switch that. The red is how fast water is leaving. The blue is how fast water is going in. At this time over here, the water level is... One more time. Water level is increasing. What over here? Increasing? Decreasing? Not sure. Water level at this time right over here, I hit the red function. I keep going up, I hit the blue function. Which function's taller? The blue. If the blue function is taller, the blue function has a greater value. So here's what I'd like to do on the graph. Over here, what was the water level doing?
Decreasing.
Water level decreasing over here.
Increasing.
Increasing. Where does the switch happen? At the intersection, because at the intersection, the way we're going to interpret that is water is going in just as fast as water is coming out. So the water level just stays constant. So if I draw like a little dotted line here, before this we're going to say W of t, what do we say about W of t?
Decreasing.
Oh, W of t is decreasing because L of t is greater than A of t. After the intersection point, W of t is increasing. And that's because L of t is less than A of t. So to answer this question, on what interval is the water level increasing? Right, you're going to go find the intersection. Miguel, if you can find the intersection. The answer is going to be starting at the intersection point, going until... I want to be really careful with the answer to this one. All that you get to see is 0 to 60. So if the only thing you can see is 0 to 60, then the water level is going to be increasing from 17.685 all the way until 60 because there's no other intersection point. So for part D, I'd say something like W of t is increasing on, Miguel, what was the number?
17.685.
17.685 to 60 because A of t is greater than L of t. All right. Questions so far? Is everybody okay? We're hanging in. All right. Last question. Melissa, can you read this one?
E.
Part E. Yep.
During the first hour, when is the water level lowest? Justify your answer. To the nearest gallon, how much water is in the pool at that time?
Oh my gosh, I love this question. I'm having flashbacks already. When is the water level lowest? Oh, I hope you're having flashbacks with me here. Water level lowest. There's another way I could have said this. Another way I could have asked this question. Instead of the word lowest, a really good calculus word is?
Minimum.
Oh, not just minimum. Oh, not just minimum.
Absolute.
Oh my God, it was music to my ears. The angels were singing again, just like Friday. Absolute. My life flashed in front of my eyes. It was amazing. Water level lowest, the absolute minimum. I want to know when the water level is an absolute minimum. It's been a while. What did we do? When could the water level be lowest? When, oh when could that water level be lowest? Fabricio, when could that happen? When, oh when could that water level be lowest? I swear I might be doing this for a reason. Where, oh where might that be the lowest? Jasmine, when might the water level be lowest?
When you do the app,
No, not for that. The absolute, it could be lowest at the endpoints. We always check the endpoints. That's when you might be the lowest. Sorry, Jasmine, I understand that's the same motion for absolute values. So I'm going to look at time 0. I'm going to look at time 60. Mrs. Blakely at East End does a great job teaching her students to set up a little table. And so the table over here is like the time. Over here, this is the water level. At time 0, what's the water level? How much water?
10,000.
10,000 gallons. At time 60, how much water? 10,000 plus the integral from 0 to 60 a of t dt minus the integral from 0 to 60 L of t dt. And I think we already did this one, right?
yes,
What, Brianna, what was the value?
10218.989.
Passion. That's passionate. So we check the endpoints. Always check the endpoints. And there was something else. There was another place you would check. Some other place. Some other, not midpoint, we called it the candidate sometimes. If I look at this graph, when could the water level be lowest, Miguel?
When it's regional.
Let's back it up a little bit. At time 0, what's happening with the water level? The water level is decreasing. So could the water level be lowest at time 0?
Yes. No.
Because you guys just told me what's happening to the water level.
It's decreasing.
It's getting lower still. So at time 0, this can't be the lowest. What about over here? Could this be the lowest?
No.
Water level's decreasing, but not lowest because I'm still decreasing. When do I stop?
The intersection.
At the intersection point. That's when you switch from lowest to, it starts to increase. So this last value that I want to put in the table, Miguel, what was the intersection point?
17.685.
17.685. This guy here is my candidate. The intersection point is the candidate. To finish this off, I would say, all right, so you need me to do 10,000 plus, you guys know what I'm going to do because I don't want to write this number out all the time. I'm just gonna say call this 0 to like b. A of t dt minus the integral from 0 to b, L of t dt. And I'm just gonna say that this is b. So if we had time, I'd ask Miguel to find the intersection point, call it something, and then find out how much water is there at that time. And I'll tell you that this is like 8,000 and something. It's a really bad estimate. So based on your answer, when is the water level the lowest?
The candidate.
It's lowest at the candidate, but you have to check the endpoints and the candidate, and you'd say, oh, the water level is lowest at this time. Done. We're going to play around with these tomorrow. We're going to play around with these Wednesday, Thursday.